Hello and welcome to this video on injection blow molding with Ansys Polyflow. Our first step is to read in a mesh. We'll set the units to meters. Take a look at our mesh. We've got two molds and a pairs in between them. The first step is to use template. Use a type blow molding thermoforming. In this case, we have no fixed molds. We have two moving ones. And we'll use a duration of 5 seconds. Wait for the outline view to populate. Take a look at General tab. You see these are 2D shells. It's transient simulation, task blow molding at duration of 5 seconds, and the inertial effects is turned on. We'll look at the fluid next. Look at the density and the viscosity. We'll update that to 1/4 Pascal seconds. Next step would be to set our cell zones. So the first one, the fluid zone, would be our person. And we have a inflation pressure, negative 10,000 pascals. And the time dependency, we'll have a expression for that, which I saved in text editor. So we'll copy paste that there, switch to expression. Paste that. Display, make sure it's there. Next one would be the moving mold. This will be, we'll pick our left-hand mold for this one. And we'll set our velocity in the Z direction. Use the expression. And the mold 2 would be our mold right. And we use the second expression. Use that. Display that. So like in this case, the darts are pointing towards what would be the solid portion of the mold. So these darts are pointing the correct direction, but the time dependency for the velocity means that as the mold progresses over time, the molds will come together, sandwiched together. Next thing is to set the layers of fluid. This would be for the person. Set that to a constant thickness of 0.03. Find the fixed edges, the top and the bottom. So these are 0 velocity. We'll pick both top and bottom. Now contact between the fluid and the molds. So we'll pick the person for the fluid. In this case, the left mold. Make a slight adjustment to the penetration accuracy. And do the same thing for the contact with the right-hand mold. Next would be fluid deformation. The fluid is what's deforming, so we'll pick the person. And then drop down to adaptive meshing. And again, the person is doing the mesh adaptation, so we'll pick that. Then molds of contact, we'll pick both molds. We'll leave angle and curvature for method. We'll leave the, well, maybe update the minimum, something a bit bigger, maximum size, something bigger as well. Change the tolerance. Leave the critical distance alone. Next step is going down into the solution, derive quantities. We'll add tracking vectors, and we'll include the vectors initial relative to the this direction D, and we'll update that direction to the Y direction using 0, 1, 0. And we'll enable the self-contact to give warnings if there's self-contact. Next, we'll go calculation activities. We'll update convergence criterion to something user. Make a tighter convergence. Update initial time step size, something smaller. Minimum, something a little smaller. Same thing with the maximum. And we'll leave maximum number of steps alone, and we'll tighten the tolerance. Lastly, we'll go to the run calculation, perform a check, confirm everything is okay, and then we'll hit calculate. You can watch progress in the transcript, and we can see convergence history and the plots. So we'll come back when it's finished. We're back after the simulation is completed. We'll look at some results. Say we'll look at the contours. Look at contours of thickness. Pick on the Pearson. Display. And we can animate this using the time step animation. So the molds are moving together, pinching, and now the inflation. That concludes this video. Thank you for watching. Bye-bye.